John Cleese would say. We're going to talk about software-defined radio. Now, look, you may think, oh gosh, I don't know what that is, and I'm not sure I want to know what that is, but you'll find it actually quite interesting. Let me just take you back to those golden days of yesteryear, which is to say back to 1960, when Frank Drake was at a radio telescope in West Virginia, Greenbank, West Virginia, and he was doing the first radio search for alien transmissions. Now, he needed a receiver to do that. He had a big antenna. It was 85 feet in diameter, actually, which is pretty big. It would impress the neighbors if you tried installing it in your backyard. Well, he didn't want to spend a lot of money on new equipment, right? The observatory would have said, you're going to spend money just to listen for aliens. That might have given him a bad name. So he didn't do that. He used existing equipment. And he had a receiver down there, which was the kind of thing, you might buy if you're a radio amateur. I mean, it was, just a commercial grade receiver. But he didn't know where on the dial the aliens might be transmitting. So he rigged up a little thing with rubber bands and strings and a little motor. And what that motor did was just sort of tune the radio up and down the dial every couple of 20, 30, 50 seconds, maybe a couple of minutes. It would just go up and down the dial. And he just kept waiting until he heard something. That's the way it was done then. Well, these days, it's high tech all over the place. And we have very specialized equipment to listen to tens of millions of channels simultaneously, because we still don't know where ET might be broadcasting. Okay, well, what we're going to talk about today is how we can get away from that very specialized and often very expensive hardware to build the most general purpose receiver you could wish for by doing it in software. Computers are fast, computers are inexpensive. We have people here from GNU Radio. In case you don't know how to spell it, I don't know how to spell it. It's GNU. And I'm going to ask all the folks here that are logged in on your screen. You can see their faces now. Their social security numbers are pinned to their chests. Maybe they could introduce themselves, beginning with Alex.
Yeah, hello. My name is Alex Pollack, and I'm the Science and Engineering Operation Manager up at the Head Creek Radio Observatory. And I'm working on the Allen Telescope Array, which is an antenna with 42 antennas, on array with 42 antennas.
And did one of them go missing, Alex? Is that why you had
yeah, I thought kind of, oh my God.
You can see two of those antennas behind, Alex. So they're aimed at, it looks like Mount Lassen, but I don't think there are many aliens there. Next is Steve Croft. Tell us who you are, Steve.
Hey, Seth. Steve Croft. I'm jointly with UC Berkeley, where I'm the project scientist for Breakthrough Listen on the Greenbank telescope, and at the SETI Institute, I'm helping out with this partnership between the Allen Telescope Array and the SETI Institute more broadly in GNU Radio.
Ben.
Yeah, so my name is Ben Hilburn, and I'm the president of the GNU Radio project.
That's straightforward. And you, by the way, the other two gentlemen so far are here on the West Coast in the Bay Area. Well, I guess Alex not really in the Bay Area. The Hat Creek Radio Observatory is about 300 miles north of San Francisco. But Ben, you're on the East Coast, right?
Yeah, that's right, just outside of DC.
Outside of DC. And Derek.
Hi, I'm Derek. I'm the principal investigator within the SETI Institute. But before that, I was, well, still am, a GNU Radio officer, and I represent the project in the community within SETI Institute.
Terrific.
And I'm here in Cardiff, Wales, so a little bit farther afield.
Cardiff. My goodness. Okay. Not too far from Bristol, I guess. Huh? Across the water or something like that.
Just across the channel.
Okay. Well, maybe actually we should point out, and this will come back to the conversation, that there is now a very official and a fruitful liaison, an arrangement, I don't know what the correct term is, between the SETI Institute and GNU Radio. But first, GNU Radio. Ben, it sounds like you're the guy to tell us what is GNU Radio. It sounds like something pretty GNU-y.
Yeah, so I think there's kind of two answers to that. One is, what is it from like a technical perspective, right? And then what is it as a community? And I think they're both really important. So the straightforward technical answer is, it is a software project building a framework for digital signal processing. And it's an open source project. But more largely, GNU Radio is a global community of academics, researchers, hobbyists, government, all using open source technology to further research, education, and whatever particular technical pursuit they're working on.
Okay, so, but if I were to say, look, I'm not quite sure I understand all of that and why I would be interested in it, can I go to my local, I don't know, technical, I don't know, an electronic store and buy a GNU radio? Can I take it home in a box?
No, you can't. So GNU Radio itself is not a hardware device. It's a software toolkit that you can then either use standalone in like a purely simulation kind of mode, or you can use with hardware. So it's a software format that lets you exercise radio hardware to do whatever you want to do.
Okay, if I understand that correctly, I mean, when I was a kid, and I think radio had just been invented, or maybe not yet quite. If you wanted to build a radio, you'd assemble some tubes, maybe even transistors eventually, and a whole bunch of coils and condensers and resistors, a whole bunch of parts, which were actually all analog parts. They were things that actually did something. No digital things were involved at all. And you'd make a little tuner, right? And then you have a whole bunch of amplifiers, and at the other end, you'd have earphones or a speaker, and you could tune in your local country and Western AM station, which was, after all I ever listened to. Now, you're saying, no, the heck with all that. You don't need all those parts. We'll just do it in software. But why would you want to do that? Why get rid of all those parts? They're kind of nifty. Yeah,
I think you nailed it. So the analogy that I typically use is the evolution of just computing, right? From the giant machines where to make a program or to make it do something, you'd have to have an operator there, right? Plugging in wires and literally connecting paths, right? To do some math problem. And then now, decades later, we came about with software programmable processors. Software radio is exactly the same thing, taking the analog discrete hardware that you described and moving as much of that functionality as possible into software, right? And so there you get many of the same benefits that you would get from the transition of completely hardware computing to programmable computing, right? You get configurability, the ability to test and prototype just by changing code and not by resoldering a board or refabbing silicon. You can not just reconfigurability from a design perspective, but once it's running, right, you can do many different things simultaneously with the same data streams. You get interoperability, right, between many different hardware devices. And you can take an application that was written for one piece of hardware and take it and use it with another, right?
Okay, so in fact, it's equivalent to buying every radio in the world, if you will, in one box, and you can switch from one to the next. You don't have to have this radio over here for your AM stuff, and over here is your FM radio, and oh, here's the shortwave radio, and so forth and so on. You can have them all with software packages. Derek, tell us a little bit about why you find this interesting. Why are we involved?
So one of the things that I absolutely got pulled into software-defined radio originally by was actually these little tuners, which you can just pick up very cheaply online, eBay. Yeah, Steve's got his on hand. Come on, Alex, where's yours? It's got to be within reach. And these are like $15. They're great. And they were originally designed just to receive digital television. And somebody clever found there was a debug mode that would let you dump out this raw data. And now there's a whole host of applications that can consume that data, and you can, download weather data from satellites using something that was meant to be a TV tuner. Or you can go and listen to your local FM broadcast station and get the music. So for me, it was that fun bit being able to experiment really easily with something that was quite cheap.
So sort of like an Arduino. Suddenly, there are just a myriad of possible applications for people who just like to fiddle around with this stuff. Have you done that yourself, Derek, by the way? Have you,
quite a bit.
Yeah.
And that is a great analogy. This is absolutely the Arduino of radio receiving. It's a shared, common, cheap platform that has just made so many things possible to experiment with. And then you can go out and you can buy the much bigger computer if you ever need it. And some people make huge software-defined radios. And SETI Institute is absolutely one of those groups that has truly enormous software-defined radios already.
I noticed our producer behind the scenes, we have several of them actually, but Rebecca McDonald has been typing in, or maybe it's Jasmine, it may be Jasmine, but in any case, typing in some of the locales that people are watching this on their software defined Zoom devices, and everywhere from Nova Scotia, Harrisburg, Berlin. I think I saw Inverness, which is this giant kind of lizard thing that's watching there. And so that's really great. And I hope, by the way, you'll have some questions, because in another maybe 10 or 15 minutes, we'll go to Q&A. I do want to find out why this is so interesting for SETI, though. Steve, maybe you could start us off there.
Sure. Yeah. So Seth, you started off by describing the experiments that Frank Drake did at Green Bank back in 1960. And a lot of that was sort of custom hardware, a lot of it sort of just built for one-off experiments. And there's actually been a move in the SETI community towards using more commercial off-the-shelf products. And so we go out and we buy a computer. I mean, we don't sort of quite go to Best Buy and just click add to cart, but it's sort of something a little bit like that. And we buy computers, we use fast GPUs, the graphics processing units that people use for gaming on their computers. And we build just, essentially big software-defined radios that tune to, as you were saying now, millions or even billions of channels at a time. So you've got a little device like this. Well, if you've got $20 to spend, that's great. If you've got, tens of thousands or hundreds of thousands of dollars to spend, you get a bigger version of this and you plug it into a bigger telescope and then you get more data.
So from the standpoint of somebody who says, okay, the technology is modestly interesting, but I'm interested in finding the aliens, how does this help?
Well, I think one of the things that's really exciting about the partnership with GNU Radio is it gets a bunch more smart people in the room. And so in addition to sort of having this hardware that everyone knows how to use, if there's kind of a universal interface, if you don't have people from outside coming in, they've got to figure out, how do I get into this sort of special format that the SETI folks are using? How do I understand how to control the antennas and all the interfaces? And I mean, as scientists, we're not particularly good often at interface design. We don't sort of put out nice polished products like the tech industry does. It's all a little bit kind of, chewing gum and string and baling wire. And so to have something where people can log in and basically say, I want the data that's coming off of your antenna and I want to run my algorithm on it, maybe my detection algorithm that's a new kind of whiz-bang ET detection algorithm, then they can bring that to the table in a much easier way. So that's sort of what's really exciting for me.
But would you say that maybe the big win here is that you might be able to observe more or monitor more of the radio dial, more of the spectrum simultaneously than we can now? And that essentially speeds up the search. I mean, if we're going to find a signal, the faster you can do the experiment, the sooner it's going to happen. And it won't be something that you're dead before we find ET.
That's right. And I think sort of one of the nice things as well about radio telescopes is that different people can sort of subscribe to the data that's coming out of it at the same time. Just as there are, I don't know how many people are watching this live stream that's going out, everybody's getting a copy of it. You can also have multiple people who are getting a copy of the signals from the telescope at once, and they can each do their own processing. If somebody's interested in doing an ET search, but somebody else is interested in looking at satellite transmissions or searching for pulsars or doing something else, then everybody can do that without sort of stepping on each other's toes. And so there's this idea of sort of, there's a term called commensal, basically, which basically means sort of we're all eating from the same table, but we're not sort of stealing each other's food, which is good.
Yeah, it reminds me of big accelerators that the particle physicists would use, because an accelerator is a very expensive piece of equipment, but they take the beam, if you will, and they split it up to a whole bunch of different experiments, that kind of thing. Alex, you're the man on the spot. You're up there at the Allen Telescope Array, where it's obviously cooler than down here in the Bay Area, judging by that jacket. How do you see this affecting what's going on at the antennas?
Yeah, so Steve mentioned the commensal mode, and that is something which kind of we set up here as well. So we installed a couple of months ago, 2 months, I think, or a month ago, 2 USRPs, which are kind of the same hardware as that small stick, which Derek showed, but much bigger and more expensive, so they can process much more data. And so for us, because we do regular observations with the ATA, and if the GNU Radio community wants to take data, they're basically hooked up to the output of the antennas now, and they can take data with those USRPs 24/7 with it. And if we're not using the array, they can even use the array themselves and point it. So,
okay, so that this allows participation by a lot of people who might have their own ideas about how to process data coming out of the Allen telescope array in such a way that well, you guys aren't slicing and dicing this data the right way to find the signals we're looking for. I'm going to try myself.
Exactly.
Yeah.
So they can basically kind of either stream it, and I think kind of Derek, we're together with Derek, we're working on kind of opening up to the community. So one plan is to kind of just put the data, the raw data which we get, out on a server where you can download it, and then you can try kind of analyzing, or you can analyze the data yourself, or you can also kind of get involved and work on the development of the data analysis, online data analysis of the data stream which comes out, and then apply your kind of software to it.
Okay, so it's kind of citizen science in a way, right? Yeah. And by the way, if any of you guys want to chime in, I hope you will do so. You could raise your hands if you wanted to be polite. So it looked to me like Derek was about to raise his hand.
If I can, yeah. This is one of the things where I think we've been talking about one portion of this, which is the data capture. And you started off at the beginning, saying how large the antenna was that a lot of the initial radio astronomy was done on, and how the neighbors would kind of notice. Where I'm living, people would notice even a 6-meter dish. So getting access to the Allen telescope array is just mind-bending for me. It's great. But that capturing of the data is only the first part of the challenge here. You have to figure out what to do with that data. And the cool thing is, a lot of what Alex will do with the data, or Steve will do with the data, or someone else completely, separate from SETI and around the world will do with the data. A lot of those are the same operation. We start in the same place, and we may want to all do them in different orders and our own little tweak. But there's so many of these shared pieces that wouldn't it be great if we could just reuse those pieces? So nobody has to reinvent these basic building blocks of the data processing. And that's exactly what GNU Radio brings to the table, is literal building blocks that do these basic operations for you. And one of the things that we don't have a lot of right now is the fundamental radio astronomy operations, pulsar de-dispersion, and some of those specialized pieces of signal processing. They're things that are bread and butter for the SETI Institute and other radio astronomers, but we don't have that yet in GNU Radio, but we have everything needed to build that. And so our hope is that when somebody does build it, they'll then share that. And that's a fundamental philosophy of GNU Radio.
I mean, this reminds me of the predictions that were made by the people in citizen science years ago about, for example, curing cancer. Want to cure cancer of the elbows or something like that. And we don't know how to do that. But if you put all the data that is collected about people's health, including those that develop this cancer, and you have, a powerful enough, cell phone, eventually, maybe you have enough compute power there. You download some of those data, you run your own sort of analysis. You say, well, is there any correlation between that particular condition and maybe their diet? And then you find out that, fried asparagus or something correlates well with this condition. And, so you, who knows from nothing about medicine, can in fact make these big breakthroughs. You're going to see that in astronomy. I wanted to ask Ben here, because Derek's given a great explanation that this is sort of a modular thing. If I want to use GNU Radio and I buy one of those dongle-looking things that Derek held up there, can I get to GNU Radio? I mean, can I just go on Amazon and buy it, or how do I get involved?
Oh, no, GNU Radio it's free and open source software. So you go to gnuradio.org and you download. You can find links there, but you can download the source code, from GitHub. You can download, prepackaged installers on pretty much every major Linux distribution, on Mac OS. There's even some on Windows. It's not something you ever have to pay for or get from a store. It's freely available open source software.
How interactive is? I mean, can I just sort of take this module over here and on my screen connected up to that module?
Yeah, exactly. Actually, so one of the tools is called the GNU Radio Companion. It's a graphical tool where you literally drag and drop blocks. And you're like, I have a radio. I'm going to do this to it, and then do this to it, and then write the output to a file, and you connect them up and hit run, and off it goes. I
got to ask you this: GNU Radio, GNU, right? Giant new unit, whatever. Where does that? I mean, I've seen GNUs. I saw them in Botswana, I think, actually. and they didn't
Yeah.
look like radios, and they probably didn't know much about radios. Where's, you know, there's a WGNU on the radio in Boulder, Colorado. I figured maybe that.
Yeah, no, so GNU actually, so GNU Radio started as a project under the GNU umbrella, and GNU is itself an umbrella project of open source. So it's actually a recursive initialism for GNU is not Linux. Sorry, GNU is not Unix. So it originally came from decades ago when computer scientists were trying to use Unix systems. But they were entirely proprietary and they didn't have access to do the kind of tinkering that they wanted. So they made the GNU project. And decades later, GNU sort of serves as this umbrella effort for large open source projects. And that's where GNU Radio started. And that's where our name comes from.
Sounds like the naming convention they used in the early days of assemblers and so forth for personal computers.
It comes from the same time period. Yeah.
Yeah. Okay. GNU Radio. All right. Terrific. Well, listen, Alex, you're up, you know, you're where the rubber meets the asphalt. So I kind of wonder, you know, how much of your effort up there has been connected with GNU Radio? What do you see coming down the pike?
So we spent quite a lot of time lately on setting up that framework, which allows people to kind of connect in, which allows the data to be captured. So there were a lot of kind of work on the end of the signal chain. So we use antennas, we collect the data is put into our signal processing room, and there we have an interface where we connect our own digital signal processing on, and then we installed the GNU Radio hardware, we installed a server, we installed kind of network switches and all of the kind of high-tech fun things to install and play with, I guess. And so we set everything up, and then we also had kind of a student project, Ellie White, which worked then together with GNU Radio and developed the whole kind of software to control the telescope. Because one thing is kind of the data capturing, but the other thing is if you want to kind of open it up to the community, you want them to be able to say, oh, I would like to look at the moon. I would like to look at what Voyager or whatever kind of you can imagine, and collect data from there and see what comes in. So there's a whole kind of project or kind of software developed now where you have those nice blocks. You don't need to know anything about how the ATA works. You know, there's an ATA block, you drag that in, you select which antenna you want to use, and you pretty much press enter target, which you want to observe. You press start and the antenna is pointing at it, and then you can collect data with the other data blocks.
So you see the future in which the Allen Telescope Array becomes, if you will, I don't know, publicly accessible radio telescope. In other words, you can control it and run your own experiment in the privacy of your own home.
Pretty much, kind of. If you kind of get involved, of course, it's kind of, you have to get involved. You have to kind of work with us on kind of development side. But there's definitely kind of the possibility of people who are kind of interested in getting involved. It's a very good way of being able to use your own radio telescope for a while.
Steve.
Yeah, maybe if I can sort of talk about getting involved. I mean, this is sort of one of the other things that I think is really exciting about this collaboration. You know, it's not just GNU Radio to help us do our SETI data processing, but it's also sort of a home for GNU Radio more broadly at the SETI Institute, sort of getting access to new sources of funding, maybe sort of new sponsors like the National Science Foundation or other sort of funding bodies that might be interested in doing some of this. And you know, there's the research side of this, there's the tech development side. GNU Radio is being used for prototyping 5G wireless. It's being used for you know, Internet of Things and all kinds of sort of modern devices that are part of our daily lives. But it's also a really exciting way of getting people engaged in an educational setting for me. And we've been using this with our students this summer. Alex mentioned one of the students, Ellie White, an undergrad who worked with us this summer. But we actually shipped out one of these little software-defined radio dongles and a little antenna like this, a bit smaller than the antennas behind Alex, but still kind of fun for playing around with. And they were able to do experiments on their computers where they could pick up radio stations, but you can also do things like decoding plane transponders. So, you know, you look out the window, you see a plane going past. What's that plane? Where is it going? Well, it's actually broadcasting a little signal that's telling you, you know, I'm United Flight 40 and I'm heading from San Francisco to JFK, and this is the altitude I'm at and the direction. And anybody with the software and with a little bit of hardware can decode that, and then you can sort of get hooked on this, and maybe you end up just like the folks who ordered these radio kits, the crystal radio kits from a magazine 40 years ago, and then became kind of the radio engineers of the present day. I really hope that we're going to get more people who like to tinker with stuff like this, who then sort of end up maybe as SETI scientists, maybe folks who are working on the ATA down the line. So that's super exciting for me.
That sounds extraordinary. I, by the way, I build a lot of those crystal sets, usually in old cardboard cheese boxes. Derek, that thing you held up, several of the people here claim that this is a dongle, and in fact, Steve just said that. Where can they get something like that? What's the name of the tuner that you would recommend for people who want to do exactly what Steve said? They just want to build a specialized radio and listen into the undoubtedly enlightening chatter of airline pilots.
So I specifically showed the all silver side of this earlier because I wasn't sure how we felt about specifically calling things out. But
you'll get a kickback.
Oh, please. No, there's this. It's a great company. RTL-SDR.com sells the one I have. Steve's got the NOAALEC one. Generically, these are all called RTL SDRs. And so you can find those eBay, Amazon, and a lot of specialist online stores, but the term is quite generic and they all work together.
I have to say that Ben knew that. He said, the device Derek is holding is an RTL SDR dongle, right? And you say it's on the order of $20. I mean, this is not 20 kilobucks or anything like that.
No, 20, and those are actually available on Amazon.
They are. See, you can become involved. And in fact, if you have a backyard satellite dish, I mean, maybe you want to do your own SETI experiment, although not a whole lot of sensitivity there. I'm trying to look at some of the questions. There aren't too many. I think people have just been so blown away by this, but let me just see. People did ask about SETI at home. I'm not sure that this still applies to SETI at home. Steve, that might be something you want to weigh in on. As I understand, SETI at home has gone on vacation to the Caribbean or something.
Well, SETI at Home, I think, was a really successful project to get people engaged with processing data. They did a bunch of processing really over about 20 years, and now they're sort of taking a step back and actually doing the analysis of the results that they got to see if there's anything, that we want to follow up in there. I think, SETI at Home was something that people sort of clicked, download, and install, and GNU Radio is something that is a little harder to install on your computer than SETI at Home. You need to know a little bit about computing. Maybe if you have a Linux computer, if you sort of delved a little bit more sort of beyond the surface of computing, maybe you're sort of more of a mindset to get involved with this. But it's sort of less passive and more engaged in the sense that you could do SETI at home, but with some hardware, with some software, so to get engaged with this again, as we've been doing with our students. So it's a different kind of project. It's not sort of replacing SETI at home by any means, but I think it's sort of an interesting alternative to that kind of thing.
Given the liaison now between GNU Radio and the SETI Institute, I mean, obviously the applications to SETI come to the fore. But I sort of want to ask any or all of you just this. Suppose, I'm one of these guys who just likes to, one of these people likes to tinker around, and instead of reading books or watching reality television, I buy one of these dongles. I download GNU Radio. It's open source, right? I can modify it if I want. Okay. And, I start doing something and I pick up the signal, right? Does that mean that the Swedish Academy of Sciences is going to invite me to come to Stockholm and collect that prize? I mean, who gets the credit here? You guys don't know. All right. All right.
Science is a shared effort, right?
Yeah, well, maybe multiple people. I mean, there's plenty of precedent when it comes to the Nobel Prize in not necessarily giving it to the people who actually get the work, but you might be the work. I'm just going to quickly look. Ben Hilburn, who I think was the same person who recognized that dongle, said the major benefit of open source is that you get more people involved than you would ever be able to afford or access otherwise. And has that been the case, Ben? I mean, are other people actually futzing with the source code?
Oh yeah, absolutely. And this goes to a little bit about what Steve and Derek were just talking about, which is one of the amazing things about having a commons, in this case, open source GNU Radio, is you get people that are working on things that are not interested in the area that you're working, but they have shared problems, right? So maybe there's some signal processing block that you need to find ET, right? And there happens to be someone who's working in 5G, right, who doesn't care at all about finding ET, but they are an expert at that signal processing block, right? You can benefit from that person's expertise because everyone is working on the commons, right? Even though you might be interested in different things. And so you get access to people, and people, people get involved in building this common baseline that everyone can benefit from that otherwise wouldn't come together.
I'd like to just quickly jump in and point out one thing that I guess Ben and I really know, and maybe no one else does. GNU Radio has no company behind it. There is not a group of people sitting in a room writing this software. So when we say, we have contributors to the project, that's all there is to the project in many ways. Not entirely, but pretty close. It's almost entirely individuals and companies using it and then saying, but we need this one more piece, writing
Derek,
it and contributing it.
Is it easy to find? If I'm one of these people who wants to download GNU Radio, do I just Google GNU Radio and find the download?
GNUradio.org. Yep.
Okay.
And there's a getting started button that drops you onto a wiki, and the first thing you hit is the install page.
And did this kind of just to wrap up here, because we're really out of time. I just want to ask Alex, because many of the people who are watching this don't realize that Alex is an extraordinary engineer. And I usually don't mention that because people will, ask him to come over and fix their air conditioning or something, which he happens to be good at. But, Alex,
only for signal processing rooms.
I figured that maybe you've already started fiddling with this capability of doing it, not in terms of stuff for the Allen Telescope Array, but for your own interest. Is that possibly true?
Yeah, it's kind of, I think that's a very, very good point. So I've done some student projects very early on. So even before I really thought about kind of becoming a scientist and joining in the SETI Institute. So we kind of found, so when I had the first contact with kind of astronomy, I thought like, oh my God, that's amazing. I want to build my own radio telescope. How can you do that? And then I thought, then I had to do an engineering project at my undergrad degree. So I got people together and said like, come on, let's build a radio telescope as a project. And we looked at the data signal processing, and usually kind of if you buy specialized equipment, it's very expensive. So we came across the whole SDR sticks, the whole GNU radio. And so that was the first time I heard of that and said like, come on, that's brilliant. We can buy a stick for $12, $20 and then have our digital signal processing. So we just need a satellite dish. We found one from the neighbors, which they threw away, a TV dish. And then as a receiver, you can buy those just an old kind of coffee can, which is an aluminum coffee can, which is roughly the right size. You stick a wire through it, you put some amplifiers on it, connect it to the SDR, and then you point it up, and you can pick up the neutral hydrogen line, or kind of look at Cas A. So it is very straightforward to do, and it's a lot of fun to do those. And at that time, because I did not know much about it, I just Googled for kind of tutorials, and there's a lot of kind of tutorials and examples on how you can build your own radio telescope with a coffee can and with a few kind of small amplifiers, so with a very low budget, and then do the whole signal processing with GNU Radio. So there's a lot.
Well, all right, then I will end it here, but point out to people who might be interested in this. You might think, oh, well, look, yeah, I've got a backyard satellite dish somewhere. My uncle has one, and I could use GNU Radio and do my own SETI experiment. Well, why should I? Alex has 42 antennas, such as the two behind him, and they're 6 meters in diameter, and there's no way I'm going to be able to compete with that. But keep in mind that all the SETI research since 1960 added together has looked at, well, it's completely analogous to saying you're going to go to Africa and look for GNUs, if it's a silent G or not, you're going to look for them, and you give up after one city block of Africa. No GNUs here, right? There's still value in looking in parts of the sky that nobody has looked at, which is essentially the entire sky. I want to thank Alex, Steve, Ben, and Derek for being with us today, and thank you all for participating in SETI Live by having your neurons tune into us today. We'll see you next time.
Give us 2 more seconds, Seth. There's one
Oh.
thing that people should know. Next week, there is a completely free conference about GNU Radio, and SETI is going to have a really big presence there. So
Where do they find it?
GNUradio.org. They'll find it on the homepage. The conference link is in the comments on a bunch of these live chats. It's just called GNU Radio Conference. It's running Monday through Friday, and all the main track talks are free.
Terrific. Thank you, gentlemen. Thanks, everybody. And thanks to the people behind the scenes, too. Lee, Rebecca, and Jasmine.